sketching a probability distribution. So what we mean here is curve sketching. Versus plotting. So what we're trying to get here is trying to get main features right. So the main features or trends right, as opposed to a plot where you're trying to get all values correct. Okay, so that's important here. So you're trying to get the main features or the trends, general trends of the probability distribution correct if you're doing a sketch. So let's look at this. So with a PDF, so key features are where it is on or off. That's important. Has to be non-negative, so you don't want it dipping below the x-axis. Area is 1. That's important, but these others are more important here. Other things that are nice, so that you want to look into, is if you have one or more peaks. If you have a tail region, so you have a region that's pretty large relative to the rest of the curve that, you know, has a bunch of small values. You want to know if there's a tail region and get that on your sketch. If you're talking about discrete, there's a few ways to do it. So if you have discrete versus continuous, if you're talking about discrete, usually you want to use a bar graph. You could also use a Dirac delta function, but that's a bit more advanced. If it's continuous, you want a smooth curve. It could be, you know, piecewise continuous, but next things that are important, what does X represent here? That is possible outcomes. And what does Y represent? Well, on the discrete case, the y-axis is just going to be probability of seeing X. So it's the probability of seeing a particular observation. On the smooth curve for the continuous case, the y is just going to be your probability density function. It's a little bit more difficult to interpret relative to the discrete case where you can just read off what the value is. Okay, CDF. So here there's a couple of key features. This is going to start at 0. It's going to end at 1. Another feature on this is it's monotone increasing. So that means it can't decrease. That's important. So it's always going to be an increasing curve. The reason it can't decrease is your PDF is non-negative, and the PDF is the derivative of the CDF. So if this can't be negative, that means this can't decrease. Again, you have discrete versus continuous. With the discrete case, you probably want to use a bar graph. It's also fine to use a step graph. The advantage of the step graph is that it's exactly the same as the continuous case, so that's useful. For the continuous case, you want a smooth curve. For both of these, again, X is possible outcomes. And remember what CDF means. This is cumulative distribution. So what the y-axis is telling you is the probability of X being less than some specific value. Okay, for both of these. So it is going to represent the exact same thing. It's the chance of seeing any observation less than this value.